For the reteach today, we are going to look at percent problems. So let's remember kind of the general format for percent proportion is over of equals the percent out of 100. So this is always 100, no matter what. We're plugging in the percent here. The is and the of, the is, which stands for the part, and of stands for the whole, sometimes are the trickier parts. So let's look at problem number 1. What is 15% of 95? So first thing I'm going to do is I'm going to set up my blank proportion. I always look for the percent first. So in order, 1, I'm looking for the percent, okay? Because I think that is easiest. It's either going to have the percent sign like it does here or the word percent. So the percent sign is there, that tells me the percent is 15. Next thing I look for is of. And specifically, the whole comes after the word of. So I'm finding the word of, and the part that comes after says of 95. So that tells me the whole is 95. Which by default means we should be solving for the part, which makes sense. Is tells us the part, and it says what is. We don't know what is. And now I'm going to solve this proportion. I'm going to multiply 95 times 15 to get 1425. Divide that by 100, and I get 14.25. Let's try another. 25 is what percent of 125? I'm going to set up my blank proportion. First thing I look for is the percent. I don't see the percent sign. I do see the word percent. It says what percent. That means we do not know the percent. Next, I find the word of. It says of 125. That tells me my whole is 125 because it comes after the word of. And then last, 25 is. That's telling me 25 is the part. And let's go ahead and solve. I'm going to multiply my two numbers that are in the same diagonal. So I'm going to multiply 25 times 100, which is 2,500. And I'm dividing by the number that's in the same diagonal as the variable. So I'm dividing that by 125, and I get x is equal to 20. We were solving for percent, so x is equal to 20%. All right, number 3. 150% of what number is 120? So, fill out our blank proportion. Look for the percent. I see the percentage here, 150. Looking for the word of and what comes after it, it says of what number? That's telling me that we don't know the whole. And then the keyword is 120. Tells me that 120 is the part. So we are solving for the whole. I'm going to multiply the two numbers in the same diagonal, which is 120 and 100. And that equals 12,000. Divide that by the number that's in the same diagonal as the variable, and we get x is equal to 80. So in this case, our whole is less than the part because the part is 150%, which is greater than 100. Number 4, 63 is 70% of what number? So I'm setting up my blank proportion. Looking for the percent first, I see 70%, so that tells me that 70 is my percent. Looking for the word of what number? That means we don't know the whole. And then is, that clues us into the part. 63 is, so that is our part. Going to solve. Multiply the two numbers in the same diagonal, so 63 times 100 is 6,300. Dividing by the number that's in the same diagonal as the variable. So 6,300 divided by 70 is 90. So those were basic percent problems. Let's look again now at percent word problems. So Joakim made 25 out of his 40 free throws. What percent did he make? So we can still apply a lot of the same parts of this, right? I'm going to set up my blank proportion out of 100, and I'm still going to look for my percent first because that is the easiest thing to find in my opinion. I don't see the percent sign. I see the word percent, and it says what percent, which is telling me we are solving for the percent. Now I'm looking at the other parts. What we need to remember is we have the parts compared to the whole. So we're comparing those that he made compared to the total amount that he threw. So he made 25 of his shots out of a total of 40. And of was the number 40 did come after the word of, which often clues us into the whole, but sometimes we have to be careful with word problems because of is a pretty common word. So now that it's set up, we can solve. I'm multiplying the two numbers in the same diagonal, and I get 2,500. And I'm dividing by the number that's in the same diagonal as the variable, so 2,500 divided by 40, and I get 62.5. We were solving for the percent, so it is a percent that I'm going to add on to my problem. Number 6, Maggie earned 80% on her social studies test. If the test had a total of 65 questions, how many did she get right? So let's set up our blank proportion out of 100. Look for my percent first, and I see my percent sign, so I am plugging that in. Now let's think about what this problem is talking about. So it says the test had a total of 65 questions. How many did she get right? So the part is going to be the question she got right versus the whole is the total questions. That's all of the questions. So the other number that's given to us, 65, is referring to a total of 65. So that's our whole. The total goes on the bottom. We are solving for the part. It's saying how many did she get right? We don't know. So to solve, I'm multiplying the two numbers in the same diagonal. So 65 times 80, which is 5,200. And I'm dividing by the number in the same diagonal as the variable, and we get 52. And what were we solving for? How many she got right? So 52 correct, or 52 questions right. One more from that second lesson, and then we'll move on to percent change. So 68% of Valley Creek students attend this year's homecoming dance. If 459 students attended the dance, how many students are there in the school? Setting up my blank proportion out of 100. Looking for the percent. I see my percent sign up here. I'm plugging that in right away. What we are comparing in this problem is those that went to the dance to the total amount of students in the school. So this number here, 459, that's not that, or is that saying who went to the dance, or is it saying the total? It says 459 students attended the dance. So that is our part. We want to know how many students are there at the school? That is our whole that we are solving for. So we are going to multiply the numbers in the same diagonal. So 459 times 100 is equal to 45,900. We're going to divide by the number that's in the same diagonal as the variable. And we get 675. What were we solving for? We were solving for the total students. And last, we're going to look at percent change. So, last year, David's monthly salary was $2,500. This year, it is $2,600. What is the percent change? What we need to remember is when we are doing percent change, it's always going to be out of 100. It's always going to be the percent out of 100 that we're solving for, okay? This is the change. I'm going to use a delta to show the change out of the original amount. That is what's important, the original amount. So let's set up our blank proportion here. We are solving for the percent. It says, what is the percent? If last year it was 2,500 and this year it's 2,600, the difference between those two is 100. So that is my part. That's the change. Out of the original, he originally started with 2,500. Now I have a proportion I can solve. 100 times 100 equals 10,000. Divide that by the number in the same diagonal as the variable, and we get 4. We were solving for a percent, so it's percent, and then we should identify, is it an increase or decrease? Well, we went from 2,500 to 2,600, so it increased. So a 4% increase from 1 year to the next. Number 9, Elena's math class had 24 students yesterday. She miscounted the total and recorded it as 20 students. What is the percent error? So for percent error, okay, I'm going to write it down here. Basically the same as percent change. Okay, we're still finding the change or the difference. We're solving for the percent out of 100, but this is the actual amount. It's not what number was given originally necessarily. It's what is actually accurate for the problem. So, because we're trying to figure out how far she was off from the actual amount. So I'm filling in. It says what is the percent error. That means we are solving for the percent. Okay. The difference, there were 24 students. She recorded it as 20. So the difference between those two is 4. The accurate amount is the 24. She recorded 20, that was wrong. 24 is how many it was supposed to be. So that is what we put at the bottom. Now we're gonna solve. Multiply the two numbers in the same diagonal. 4 times 100 is 400. Divide by the number in the same diagonal as the variable. So I'm dividing 400 divided by 24. And I'm getting a messy decimal, 16.6 repeating. I'm just going to round that to 16.7% error. She was that far off.